Hello, hello, hello. We're starting 9.2 arithmetic sequences. Arithmetic sequence is when you have a pattern and you can add and subtract or subtract the same number each time to find the new pattern. That number is called the common difference. This is where your little cheat sheet comes in play. Here's recursive, meaning recursive formula means we have to know our previous term in our pattern before we can know the next term. That's what recursive means. We have to know our previous term. Explicit means it doesn't matter what term we're looking for. So this little n here represents what term we're looking for. If we're looking for the 88th number in the pattern, that's what this number would represent. This right here would say, I need to know my 87th number before I can figure out my 88th number. Here, I need to know my first number. That's what this stands for. And you also need to know what number I'm looking for. And this D right here is my common difference. So for these first set of problems, if I'm looking for the arithmetic sequence, I have to first figure out if it has a common difference. So here I could add 3. Here I could add 3. So my common difference here, my D would be equal to 3. I'm asking you to rewrite a recursive. So that's this right here. So this is saying if we're looking for nth sequence, we would need to know the one right before that plus 3, because each time you're adding 3. So yes, my common ratio here is 3, and this is what the recursive sequence looks like. Here I would have to add 3. Here I add 5. There's definitely a pattern here, but this is not a common difference pattern. If you notice, these are special numbers. These are perfect squares. If I want to write this, again, this is not recursive, or this is not a common difference, but this would be like n squared, because this would be 1 squared is 1, 2 squared is 4, 3 squared is 9, but not a common difference question. Pause and try to do C and D by yourself. So C is not arithmetic sequence because you're not adding or subtracting the same number. This one is yes. My D value, my common difference would be 4. My recursive is saying to figure out the next number, I need to take the previous number and add 4 to it. So now this is where I'm going to be using my explicit formula. It's telling me it's arithmetic already. So finding the difference right here, this would be plus 5. I know that D is equal to 5 because it's saying plus 5. It's telling us we want to look for the 100th number in this sequence, so in this pattern. So that means N would be 100. That's giving us right there. So if I'm looking at this right here, I have A to the nth is equal to, A by itself is saying your first term, or else we could also have a little one here, A to the first. So our A to the first pattern would be 6. We're looking for 6. And then we have plus. We're looking for the 100th term minus 1 right there times our common difference here is 5. So this is the equation we're solving. This will give us A to the 100th because this is saying our 100th term. So if we simplify that, we get our 100th term to be 501. Here this question is saying what's the second and third term of the arithmetic sequence. Now, we know that A to the 1 is equal to 100. We know that A second, we don't know that yet. A to the third, we don't know that yet. A to the fourth is equal to 82. This is information we know from that right there. However, it's already telling us it's arithmetic, so we have to do something plus D plus D plus D to get to 82. We can set up the equation 100 plus 1, 2, 3 D's, because we're adding that common difference 3 times, would be equal to 82. And if I solve this, I know that the D should be negative because I'm moving smaller. So I subtract 100, divide by 3, I get D is equal to negative 6. Now I can figure out what my two are. So subtract 6 from this, I get 94. Subtract 6 from this, I get 88. So those would be my second and third term. I want you to pause the video and try to do C and D right now by yourself. Do both C and D. So for C, your common difference is going to be 2. We plug it in, we're looking for the 46th term. So this is where we're starting at. That's our first term. We're looking for the 46, so that's our n minus 1 times your common difference. You should have got 93. For D, Same equation here because we're making 3 jumps, so that means 3 D's. And if we solve, our common difference is D. So if we add 15 to both of these, we get 95 and 110. E, if you didn't try it already, pause and try to do E. Looking at E, we're looking for the 30-second term for all 3 of these. The first one, our common difference is 3, so we plug 3 in here. For all of these equations, notice that the 32 minus 1 is the same because we're all looking for the 30-second term. So if we simplify all these, we get 127 for A, 0.3 for B, because our common difference, you're adding 0.3 each time because, again, it's a negative, so this is actually going to be a higher number. The last one is 225. Now, we also have this arithmetic mean. So when we have the mean, it's the same thing that we have been doing when we have this space, except now if there's only one space in between, we can take their 2 endpoints. Instead of doing 3 jumps like we did in the previous question, we can take the 2 numbers that it's in between and divide that by 2, and that will give us the number in between because we're really finding the average in between these. So in this case, our third term would be 22. So in this case, our common difference, and by 22, I'm sorry, I meant 37. So our common difference would be 22. Our common difference is 22. So I want you to look at question B. If it's saying your 9th and 11th term, you can figure out what your 10th term is. I also want you to do C. So figuring out your difference, common difference, your arithmetic mean. So finding the average in between those 2 numbers. So if I do 132 plus 98, divide that by 2, I get 115. So my 10th term is 115. Here, if I'm looking for my arithmetic mean, negative 15 plus 1, divide by 2, I get negative 7. Here, I get 2.5, and then I get 7.5. And there you have it. 9.22 doesn't seem too bad. Have a great, grand, wonderful day.